Good morning, friends. Today we are going to see our first chapter from the subject Solid State Physics. Its code is PH332. It is for our semester third. In order to see the crystalline state of the material, one should first know what is meant by matter. Matter is nothing but anything that is made up of atoms or molecules. Each and everything is made up of matter. Based on interatomic distance and degree of disorder, there are various types of matters, and these are solid, liquid, gas, and plasma. In case of solids, the interatomic distance is less, and degree of disorder is also less. As we move from solid, liquid, gas to plasma, interatomic distance and degree of disorder goes on increasing. What are solids? Solids are nothing but the materials which possesses different shape and size due to their very small interatomic distance and order arrangement of atoms. In solids, there is regular periodic arrangement of atoms in three-dimensional space, or there will not be any such periodic arrangement. The materials or the solids which consist of regular periodic arrangement of atoms in a space are called as crystalline solids, whereas the materials which will not have such type of symmetry as shown in figure are called as amorphous solids. The crystalline solids and amorphous solids are differentiated via these points. In case of crystalline solids, arrangement of atoms and molecules is regular and periodic, whereas in amorphous solids, arrangement of atoms and molecules is irregular. Crystalline solid possesses internal spatial symmetry of atomic orientation. It means that their atoms are oriented in particular direction. Hence they breaks into pieces of regular shape. Amorphous solids do not possess such type of internal spatial symmetry and hence atomic orientation will not exist in them. They breaks into pieces of irregular shapes. Crystalline solids have directional properties and known as anisotropic substances. Amorphous solids don't have any directional property and known as isotopic substances. Examples of crystalline solids are silver, gold, copper, and silicon. Amorphous solids examples are glass, plastic, rubber, and wood. Then, what is crystallography? Crystallography is a branch of science that deals with studies of various forms of crystals with the help of X rays, electron beams, and neutron beams. In order to understand the science of crystallography, one should have the basic knowledge about related term to crystallography, and such terms are space lattice. Space lattice is nothing but regular periodic arrangement of points in space at infinite extent is known as space lattice. It is same as drawing a rangoli. Lattice points. Suppose I want to have a crystal structure of copper. Then in order to have a crystal structure of copper, I should place copper atoms at regular interval of time, and the points where the copper atoms are located are called as lattice points. That is, lattice points are nothing but points in space about which atoms are located are called as lattice points. Types of space lattice. There are two types of space lattices, two-dimensional space lattices and three-dimensional space lattices. In case of two-dimensional space lattices, whole crystal structure is developed by considering two translational vectors A and B as shown in figure, and the resultant translational vector T is given by n1 times A plus n2 times B. It means that in order to develop a two-dimensional space lattice, in order to have each point will have same environment as that of other, one should extend A n1 times and B n2 times, where n1 and n2 are integers. In case of three-dimensional lattice, we will have three translational vectors represented by A, B, and C, and n1, n2, and n3 are the integers. We will get a three-dimensional lattice by repeating n1 times A, n2 times B along y-axis, and n3 times C along z-axis. Then what is basis? Basis is a group of atoms or molecules attached at each lattice point. This is the lattice point and this is the basis. In order to generate a crystal structure, one should place a group of atoms or molecules at each lattice point, and thus crystal structure is nothing but lattice plus basis. So let's revise the things again. Today we have seen what is crystallography, what is matter, what are types of matters, then what are the types of solids, what is difference between crystalline solids and amorphous solids, what is basis, what is crystal structure. Do revise the things and come to next lecture. Thank you.